All right. Good morning, everyone. My name is Matt Hunter. I'm the Northeast Regional Manager for the American Wood Council. I want to thank you for joining us today as we begin our Mass Timber webinar series. We're starting off today with our Mass Timber Buildings and the IBC program, and that is subletted into several parts. What we're going to be talking about today is what's new in the 2015 and 2018 editions of the IBC, and this is program DES621. So if you're looking for continuing education credit or trying to track this down, if you're an ICC member, you can go log into ICC and self-report by looking for the American Wood Council and this title, DES621. So we have some housekeeping slides we have to get through. We have a disclaimer slide. Obviously, this isn't engineering guidance. We're just providing you with some continuing information training. Obviously, if you need engineering guidance, seek the professional guidance of a registered professional engineer. We have some slides here, some notes for our AIA members in terms of documenting their attendance in this course and obtaining certificates. And last but not least, this is a copyrighted presentation with information from the American Wood Council and the International Code Council. If there's something in this presentation you see that you would like to use, or if you'd like to obtain a copy for your personal education use only, please send us an email and we'll get you a copyright release form. We'd be happy to share some content from this program with you today. So here is our course description, which you hopefully have already read when you signed up for the presentation. Basically, what we're going to be talking about today is the code change provisions that occurred in the 2015 IBC and essentially a reorganization within the 2018 IBC. We're going to introduce you to the term mass timber, provide a brief overview of the different types of materials, solid saw materials and engineered wood product materials that make up these classifications. And we're going to introduce you to those changes in the 2015 and the 2018 IBC. So here are some of our learning objectives. Identify type 4 construction, including heights and allowable areas. Recognize the new type of mass timber products, which include cross-laminated timber or CLT. Describe the provisions in the 2015 IBC that relate to cross-laminated timber and structural composite lumber, or those are the ones engineered wood products, and summarize new provisions of the 2018 IBC related to mass timber products and the traditional type 4 heavy timber. So as we discussed previously, there is a 5-part series in conjunction with the International Code Council. I believe we have an upcoming webinar presentation coming up on December 10th. So if you've been attending some of our previous webinars in the Mass Timber series, we have another one coming up on December 10th. We hope you'll tune in for that one as well. But we're right now in Module 2, and with that, let's get right into the program. So we have a polling question here. This isn't really rated. We're just trying to get a feel for who's on with us today. So if you take a moment, when the poll gets launched, you can enter your profession, and we'd appreciate hearing from you. All are welcome. And certainly if you're not under one of these categories, just click other and maybe type in the chat what your profession is and how it relates to cross-laminated timber. Here's just a slide of who we are at the American Wood Council and what particular regions we serve. If you have any wood design related questions, you can go to the IBC website under About and look us up and see all of our smiling faces there, and reach out to us with any wood design questions you may have. So that's going to lead us to our other polling question. What's your level of experience? You're attending this presentation to get a general introduction to structural wood construction. You know, if you're an architect or design professional, have you heard about cross-laminated timber? Just reply A through E what your level of experience is, so we can gauge how to tailor the programs in the future, see who's attending, and what their level of expertise is out there in the field. I'm not going to go over our outline slide. One of the more frequently asked questions that we get was, how has heavy timber construction evolved? And what is the difference between heavy timber and mass timber in the 2021 IBC? And we'll kind of go over that for you here. Heavy timber evolved as the umbrella term in the preceding editions of the 2015 and earlier IBC. When we talk about things like tall mass timber or mass timber, we're referencing terms in the 2021 IBC, specifically mass timber. And when we talk about mass timber buildings or tall mass timber buildings, we have the same minimum structural dimensions and typical construction types associated with the traditional heavy timber, but we have a new classification for heights and areas and overall height and story areas, or story height and square footage areas, because of the increased fire resistance and fire protection methods associated with these taller types of combustible buildings. But all those materials that you see listed there, solid sawn timber, or mechanically laminated or nail laminated decking, glue-laminated timber or glulam, structural composite lumber. Again, those are individual engineered wood products that can be put together in the minimum required sizes associated with mass timber. And then last but not least, the more commonly utilized cross-laminated timber or CLT. We talk about those. Those are essentially how heavy timber has come along and basically been modernized starting in the mid 1980s over in Europe. That's where we first see the use of cross-laminated timber on a large scale. So when we talk about traditional heavy timber, I'm here in the Northeast. I'm in Pennsylvania. A really good example of a heavy timber, traditional heavy timber building would be an old mill building. Textile mill, you know, either modern mill or a streamside or a creekside mill. Typically, structural exterior bearing walls of stone or masonry, typically associated with 2-hour fire resistance. Heavy timber, sawn heavy timber, potentially mechanically laminated decking, usually in 2 layers, laid crosswise or you know, perpendicular, or even at 45 degrees for you know, 18th century fire resistance and fire and draft stopping, or mechanically, glued laminated beams put together. The picture that you see on the slide here is one of the Butler buildings downtown Minneapolis. It was constructed as a warehouse by the Butler brothers, and it had a 300 pounds per square foot design load. You can see the columns in the picture are tapering from the lower floors as they go up, and believe it or not, they're 24 by 24 square on the ground floors, and they taper to 9 by 9 columns on the upper floors. You can see there's a link there if you want to see the history of that particular building. Fully sprinklered, but again, it's outside the current classifications in the 2015 and even 2021 IBC, because it's traditional heavy timber beyond 6 stories and 85 feet, which is the current limit for heavy timber buildings in the 2015 and the 2018 IBC. So even though it's outside the current scope, the 85 feet and 6 stories, it was fairly common to do this. We used to know how to build this way. A lot of buildings are built this way. You can see there's 2 examples here from the Vancouver, British Columbia area. These examples are 9 stories. You can see we have the exterior non-combustible bearing wall, typically stone or masonry. this case, it's 9 stories, and then traditional heavy timber structural framing throughout the interior. So solidly in the type 4 heavy timber category. And these examples here, again, exceed the limits. They're both 7 stories and 9 stories here. So we used to know how to build buildings like this with pretty regular occurrence. We'd already talked about the masonry or non-combustible exterior walls. You can see a beautiful example of that. This is the original fire department building in Montreal. They wanted it to be non-combustible, obviously for fire resistance on the outside. In its current use, it has been converted to actually accommodate housing. So again, these structures are alive and well. They're very, very durable, and the longevity of them is fairly long. So some other examples of some traditional heavy timber. You can see in the photo here, we have very, very large glulam beams. It's hard to tell from the photo on the left if the beam has some camber built into it, if they're going to flip this beam over to allow for some compression loading on the bottom edge of that beam, or it's just a vanishing point in the perspective of the photo is a little skewed due to some scaling issues. But you can see in this particular example, we have a 140-foot clear span for a church, and the photo is a little dated. We're trying to get some of these updated, but I swear the gentleman on top on the right is wearing a safety harness. You just can't see it. So you can see the size and scope of these traditional glulam, just individual layers of solid sawn boards glued up into deep enough sections to address these loads. So we're talking 140 feet in length, 12¼ inches wide, and 84 inches deep. So pretty significant type 4 construction. So let's compare and contrast that with a more modern example. This is the T3 building in Minneapolis, and there are a number of these structures that are going up or have been built across the United States. The T3 stands for Timber, Technology, and Transit. And this is kind of a hallmark of this organization. I believe this is the Heinz organization, if I'm not mistaken. They are focused on sustainability, carbon sequestration, and they're really driving home that message of being sustainable, dealing with mass transit, making sure their structures are associated with a mass transit hub. They're using timber, which has typically lower embodied energy values than other competing, modern construction materials. The speed of construction, reduced labor forces, pretty quiet job site. Not a lot of trucks, not a lot of noise. You can see the crane is lifting a panel there in place, and this was utilizing glulam beams and nail laminated timber. The panels nailed up edgewise, and we'll have some examples of that as the presentation rolls on. So here's another look. We have, again, some nail laminated timber decking being supported by glulam beams. And this is the Plot 15 building in Denver. It's 5 stories with those wood elements, and they're promoting sustainability and the warm aesthetic that you get from exposed wood. So this is a mixed-use development, including retail and office space, and it has a pedestrian-friendly ground level access with open floor layouts and communal space. And this was recently completed in December of 2019. So let's look at some other mass timber products. So the text here that's highlighted as traditional has been in use for quite some time. In fact, centuries at this point. Your solid sawn heavy timber, your glue laminated timber, starting out with hide glue way back when, gluing those individual boards together for either beams or floors or roof slabs. Mechanically laminated decking, which we commonly refer to as nail laminated timber, nailing boards edgewise on edge to create a floor membrane or a roof membrane. And then we have the newer methods of mass timber products. So our structural composite lumber, that's sort of an umbrella term in the code, and we'll show you that code section in a little bit. But that includes all of our engineered wood products that are used to create the required thicknesses, the heavy timber thicknesses and dimensions that are spelled out in the code, with different products like laminated veneer lumber, which would more commonly be associated with engineered wood product beams. Parallel strand lumber, again, you see a lot of these in construction for beams, columns, and headers. And laminated strand lumber, LSL, oriented strand lumber like OSB, but beams and billets and thick sections for mass timber compliance. And then, of course, the solid sawn nominal boards put together in cross-laminated timber, and even mass plywood panels. So we're doing individual laminations to create our plywood individual pieces, and then we're gluing up those individual panels to make those billets of mass plywood panels. So we'll have some informational slides for you here on this. So this is solid sawn beams produced by Fraser Wood here. So we can make these into beams and stringers or individual posts and timbers. So these are fairly large pieces of wood that are being moved around. And you would have some criteria for these to be produced in compliance with the codes. And again, you're going to see things like ANSI standards and things in the National Design Specifications, or NDS, which is a publication the American Wood Council produces for standards associated with wood construction. So when we get into the NDS, again, you can find that document on the AWC website. You're going to be referencing Chapter 4, looking at solid sawn lumber, decking, beams, columns, stuff like that is all going to be detailed in Chapter 4 of the National Design Specifications. So moving on, we get into Glulam. We remember the gentleman walking on the beam. You saw the heights associated with that photo, 84-inch dimension. You can see this gentleman here is probably, we'll just assume he's 5'6". So we'll make the assumption that these beams are well over 72 inches in depth. The photo on the left is the work crew erecting the columns with structural steel caps and bases for the Brock Commons project, which is currently the largest, tallest mass timber building in North America. It's on the University of British Columbia campus, and it has mixed use. It's retail on the first floor, and then a total of 18 stories for the building. But they're setting the columns here for the Brock Commons building. And if you look at the insert there, the mass timber buildings in the IBC, that's the joint AWC ICC publication. Down the bottom left-hand corner of the slide, the photo image, that is the 18-story Brock Commons building that's depicted there in the inset. So glue-laminated timber, we discussed this already. You're taking nominal solid sawn boards and you're gluing them up on the edge and the strength axis, on the y-axis there, and you're laminating them together in a panel. This has been used, again, for centuries. It's a very tried and true construction method, been around for quite some time. So you can see we have some examples of that here. The Synergia complex in Quebec. You can see we're using Glulam beams and columns, and then we're using glue-laminated timber decking. Glued, not nailed. So when we get into mechanically laminated decking or nail laminated timber, just similar, but we're using a very specific and engineered designed fastener schedule to make sure we have load transfer between the individual laminations, and we're we're nailing up those individual solid sawn boards into billets of solid wood to use as floor or ceiling assemblies. You can see this is just a beautiful example of this amphitheater space where we have these arched and curved glulam beams, and there is the ability to do that with glulam beams. Typically, you get a tighter radius with southern yellow pine, a little bit more flexible than your western or refractory species like your Douglas fir species, but you can engineer radiuses and arcs in glulam beams. So it makes a very, very striking design aesthetic. So not that these are necessarily new, but we're going to go over these individual components that make up the structural composite lumber, which is a term that's defined the first time in the 2015 IBC. So for those of you that are not aware of these individual types of materials, building materials that are commonly associated with wood construction, we have a parallel strand lumber. We have laminated strand lumber, we have laminated veneer lumber, and we have oriented strand lumber. We also have an I-joist thrown in there for good measure. But you can see just a slight difference between the parallel strand lumber and the oriented strand lumber. So the oriented strand lumber that you're seeing there with the I-joist is literally chips that are laid down in perpendicular layers. It's not just a loose amalgamation of chips. They're actually laid down just like plywood. The layers are oriented 90 degrees to each other as they're coated with adhesive and they're pressed together. So it's a little bit different than the parallel strand lumber. You can see the strands are indeed parallel to each other when they're pressed together. And just like with the LVL, they're individual laminations like plywood laminations that are glued and pressed together. Typically, they're microwave cured, and all of the engineered wood products and the structural composite lumber assemblies you see here behave and perform very well in fires. In fact, they typically burn and char just like solid wood during a fire. So there's no delamination or failures associated with exposure to fire. Like I said, they perform very well. They lose their strength gradually and slowly over time. And in some cases, they outperform competing materials because their inherent mass has a structural fire resistance. And we'll get into that a little bit later in the program. So here's just an example illustration of cross-laminated timber. It's been referred to as plywood on steroids. Again, you're taking advantage of that cross-grain application. Cross-laminated timber is always put together in odd number of laminations, 3, 5, 7, or 9. And the strength axis is typically on the bottom and top. So your bottom and top layers are going to be 90 degrees to your support system, typically, unless it's a post, column, continuous column situation with a curtain wall. If you're going to go from one bearing wall to another, your bottom and top laminations would typically be 90 degrees in a configuration, to 90 degrees to the supporting walls of the bearing walls. Again, odd numbers of laminations, and you can spec with the manufacturer. You can spec almost any type of lumber. You can have included bark. You can have dense structural select. You can have architectural grade visible on the top and bottom of these based upon your budget and the scope you need for your project. So there's really the sky's the limit with the capabilities and the form and function that's available to you as a designer regarding the specification for cross-laminated timber. So mass plywood panels, you can see we have on the machine here, we have an example of a smaller lamination that's going to be built up into a larger lamination. You can see in the insert there quite a depth of individual piles or individual laminations. Again, this technology's been around since the late 1800s, pretty much perfected in the 1920s, and really started expanding throughout the U.S. from the 1920s to 1940s right through World War II. And the technology has not stopped in terms of quality of adhesives and quality control and quality assurance associated with plywood, and then that plywood being made into larger mass plywood panels. Pardon me there while I take a drink of water. So getting into what the IBC specifications are, or standards are related to cross-laminated timber and structural composite lumber. So when we look in Chapter 6 in the types of building types, structural composite lumber and other mass timber components are going to be listed under building type 4. So when we have those heavy timber materials used in the IBC, they have to meet minimum structural composite lumber sizes. So their work criteria for nominal solid sawn sizes, there are specifications for minimum glue laminated timber sizes, and then there are specifications for structural composite lumber sizes. So you can see we're typically half an inch or an inch less when we're referring to nominal or nominal versus solid sawn or nominal versus structural composite lumber. So you want to make that just make sure you're dealing with the correct minimum specification if you're looking at these individual solid sawn or structural composite lumber materials. Here's a better picture of just how cross-laminated timber is put together. So there were proposals that were done for the 2015 code development cycle to get the cross-laminated timber definition included in the 2015. So again, we talked about that previously. They're put together an odd number of laminations. You can see in this particular billet here of CLT, it's a 7-ply panel. This is a very, very stout panel. Just from experience, a 5-ply panel is typically somewhere in the realm of 7 inches. It works out to be about 6 7/8 of an inch actual measurement. And typically, most laminations, depending upon species, are about 1 3/8 to 1.5 inches. So if we take that approximate 7-inch dimension for a 5-ply panel and then extrapolate an extra 3 inches, we're looking at about 10 inches, maybe a little north of 10 inches thick for a 7-ply CLT billet that we're showing here in this picture. So as we discussed in the beginning of the presentation, the term cross-laminated timber first appears in the 2015 IBC, and you can see the text here is taken right there from the definition section in Chapter 2 in the IBC, as well as Chapter 3, the wood chapter in the IBC. There's also a reference for structural glued cross-laminated timber. And for all those designers out there listening in, if you're specifying cross-laminated timber, the document you want to reference is ANSI APA PRG 320. And if you're dealing with the taller mass timber projects that are permitted under the 2021, please, if there's nothing else you remember from the program today, the specification for producing cross-laminated timber compliant with those fire-resistant adhesives is ANSI APA PRG 320-18, and that standard will continue to be revised, but the minimum standard for the required fire resistance for those CLT panels associated with the taller mass timber buildings in the 2021 is PRG 320-18. So well before those later standards of ANSI PRG 320 came out, there were some fire testing and some research that was done to support a potentially slight increase in the traditional 6-story, 85-foot height that's in the 2015 IBC to, I believe, 9 stories and 100 feet in height. So they wanted to get some fire testing done to see what the fire resistance would be for these newer types of structural composite lumber, in this case cross-laminated timber. So you can see we have a cover slide there from a fire test report that was done at the fire testing laboratory in Buffalo, New York. And it was an E119 test, which is a standard fire test of building materials, building construction materials that's specified by ASTM. There are 2 ways to fail an ASTM E119 wall assembly test. The first is a penetration, flame front penetration of the assembly. You can see our picture here. We have a little flame licking out from the upper left corner of the wall assembly, or your interior wall assembly temperature gets too high. That's typically measured with thermocouples that are installed in the wall to make sure that the interior of the wall assembly does not get too hot. Steel and concrete, are affected by elevated temperatures negatively, just like wood is. Steel loses its heat treatment fairly rapidly if it's unprotected. Concrete will spall and wood burns. So we're not here to throw anybody else under the bus. Just equivalent risk, equivalent performance is how the code addresses fire resistance in buildings. So you can see the digital timer there, 3 minutes, 6 minutes, and 44 seconds. We were shooting for a 2-hour fire resistance, and the assembly that was tested was a five layer thick CLT panel with 1 layer of 5/8 type X gypsum wallboard on the inside, and 1 layer, I'll go back, 1 layer of 5/8 type X gypsum wallboard on the outside. Again, they were going for a 2-hour fire resistance. You can see the assembly is starting to bow here. The test laboratory was able to apply 87,000 pounds of load to the assembly. And this behavior of bowing actually kind of goes opposite of what happens in a type 1 or type 2 building with the steel studs. As the steel studs get hot, they tend to bow inwards, which pops the drywall open. With CLT, you're losing strength on the inside, so the wall starts to bow outwards. And you can see on the left where the flame is coming through there, you can kind of see that arch or that radius that's formed. So just different building materials behave differently in fire. Again, they were going for a 2-hour fire resistance, and they got a 3-hour fire resistance from simply from 2 layers of 5/8 type X wallboard applied on the inside and on the outside of the assembly. So in the 15 IBC, we have provisions to where we can use combustible materials, in this case, cross-laminated timber. We can use those combustible materials in type 1 and type 2 for balcony and canopy, or even some roof assembly applications, provided they meet the required fire resistance. Type 3, again, 2-hour exterior walls, traditionally of non-combustible materials or fire retardant treated wood in the exterior bearing wall. We can use any materials permitted by code in the interior of a type 3 building. You can see the provisions for their use there. And if we talk about types 4 heavy timber, as long as we meet those dimensions, we're fine. And type 5 is any material permitted by the code, so it'd be perfectly acceptable to use cross-laminated timber in those type of assemblies. So in chapter 6, what's our types of construction? You can see the text has been revised to include cross-laminated timber. And in this particular version of the code in the 15, those CLT dimensions are actual, not nominal dimensions. And that's just important to note if you're designing to a later edition of the code than the 2021 or the 2018, that you actually have to specify in your calculations what the actual dimensions of the CLT are. So for exterior walls 2 hours or less, you need to have some sort of fire resistance. I can assure you that this is actually a test question from the IBC. They actually asked this question in one of my recent exams. And the answer was be protected with a non-combustible material. So you can see you have some options there as a designer. You can use CLT in exterior wall assemblies with a fire resistance rating of 2 hours or less, provided you have some exterior surface protection on the outside. Again, it's a combustible form of construction. They want to make sure there's a little bit more robust fire protection associated with a combustible construction. So we have to sheathe or skin the outside of the building with 15-30 seconds fire retardant treated wood, or a 1/2-inch layer of non-combustible gypsum board or other approved non-combustible material. And you can kind of compare and contrast this level of protection, again, associated with 6 stories and 85 feet here, with the increased or more stringent protections that are going to be permitted under the types 4A, B, and C that are currently defined in the latest edition of the IBC, the 2021 IBC. So we have some specifications, minimum specifications for mass timber floors. The cross-laminated timber shall be continuous from support to support and mechanically fastened to each other. So even though that they're glued, they also have to be mechanically laminated to each other, and they should be installed without a shrinkage gap, providing swelling and shrinking is considered in the design. So all mass timber products are typically kiln dried. Cross-laminated timber is typically about 8% moisture, and just like plywood, it really doesn't move all that much because of the way it's constructed in cross-laminated 90 degrees to each other. Just perfect example, if you have a wood table or wood piece of furniture, if you have an inset, typically that inset will be plywood because it's dimensionally stable. If it was solid wood, it would expand and contract with the just natural moisture cycles in your home, and it would typically break apart because the wood has to be allowed to move. Not so much with the engineered wood products or structurally composite lumber, much more dimensionally stable than solid sawn lumber. So continuing on in the type of occupancy, chapter 6, you have some requirements for using materials, wood structural panels, to be covering them up or addressing the openings. So the 1532nd wood structural panel requirement is added into the Type 4 construction section of the code. So the strength and fire performance qualities of these wood sheathing products are well documented, and their fire resistance is well documented as well. So some additional requirements there. For floors, we talk about roofs. We're looking at a minimum of 3-ply panel just because of the way CLT is constructed. Typically, manufacturers would have to reduce their individual laminations to hit that minimum 3-inch size, just because the way the solid sawn boards are put together, typically you're going to be north or ahead of the minimum 3-inch nominal dimension, just because the size of the individual laminations that the manufacturers are using to produce CLT. Again, you're typically an inch and 3/8, inch and a half per individual lamination. So you can see just by the math there that you're going to be well beyond the nominal 3-inch thickness dimension specified here in the 2015 IBC. Interior walls, just a reminder, when we're talking about Type 4 construction, you don't get to use stick frame assemblies. Typically, you have to use the solid sawn lumber or structural composite lumber that meets those minimum heavy timber dimensions. So when we talk about things like interior walls and partitions that really don't have loads applied to them, you have to use individual layers, 2 individual layers of match boards or cross-laminated construction that's up to 4 inches thick, and they have to have a determined 1-hour fire resistance. So it's not stick framed. You have to comply with those minimum Type 4 heavy timber dimensions when you're in this category in the 2015 and later editions of the IBC. You don't get to use combustible, light frame, repetitive wood light frame or stick frame construction methods in these Type 4 heavy timber construction methods. So when we talk about exterior walls, we already saw the requirements were for fire resistance on the outside. Now we're specifying the individual thicknesses associated with these walls. So the smallest individual panel that typically can easily be made by the manufacturers is about 4 inches. The code is specifying that has to be 6 inches thick. and either it's made of non-combustible or it has to comply with the criteria listed there: 6 inches thick, or constructed with FRTW, fire retardant treated wood, or cross-laminated timber. And again, it's spelling out that that specific criteria for cross-laminated timber in 602.4.2. So here's a polling question. Which of the following may be used in type 4 construction, provided they meet the minimum dimension requirements? Don't be afraid to vote. This isn't going to hurt your CEUs or your certification for continuing education credit. We just want you to participate in the poll and hopefully gain some knowledge for this particular presentation. So your choices are solid timber, structural composite lumber, cross-laminated timber, glued cross lumber, or all of the above except D. So hopefully all of you were paying attention. The answer is all the above except D. So there is no term for glued cross lumber. It's just kind of a made-up acronym there. We want you to pay attention to things like structural composite lumber, engineered wood products, and of course the grandfather cross-laminated timber. There is no such a term defined in the code as glued cross lumber. So hopefully all of you got the correct answer, which would be E. All right. So jumping from the 2015 to the 2018 IBC, not too many changes, kind of more of a general reorganizing than major changes associated with those code change proposals that made it into the 2018. And on the following slide is just kind of a summary of where things were in the 2015 IBC and where things ended up. So the basic requirement for mass timber, heavy timber are still the dimensions spelled out in the code. Fire resistance is not calculated for heavy timber construction with these larger traditional heavy timber sizes unless it's called out somewhere specifically in the code, which would typically be the fire resistance chapter, or potentially chapter 23, which is of course the wood chapter. So the minimum dimensions for heavy timber were part of the reorganization that occurred in the 2018 IBC. And as you can see from the slide, we essentially had a lot of changes and a lot of reorganization and movement from chapter 6, sort of almost like in a subsection of chapter 6 underneath the building type 4 heavy timber to chapter 23, the wood chapter. So there really weren't any changes in the requirements. It was just sort of for ease of use and simplification. We wanted to get those very, very wood specific criteria associated with type 4 heavy timber construction in the wood chapter. So you can see almost all of them go from chapter 6 to chapter 24. So just a big reorganization, but really no major changes. So we took some of those criteria that were spelled out in chapter 6, for example, mechanical laminated decking, and we modified it to reference the specific chapter in chapter 23, section 23 of 4.9. So we just, again, pursuant to that code change, we're just moving stuff from chapter 6 into chapter 23, the wood chapter. So here's some call outs under this particular section for the minimal some nominal size of 2-inch lumber. There's also a specific reference to fastener schedules and criteria for toe nailing applications. So they're basically calling out for the designers that they need to be mechanically laminated together. And there are specific fastener schedules and specific construction methods that are used. You can see they're calling out toe nailing there in the bottom portion there that's highlighted. And they're talking about the number of nails, and there's a fastener schedule associated with that in 2304.9.3.2. And you can see the individual sections there that are referencing that much more detailed fastener schedule. 2304.8.3.3 talks about the controlled random pattern. And you can see there just from the infographic that we're nailing each individual lamination to the previous one. And then we're also having requirements for a larger, a fairly large nail, spiking the groups of individual laminations together. And that's called out in those specific code sections. Those two side nails shall be installed at each end of butt jointed pieces. So whenever you have a gap or a spline in the panel being made up of the individual boards, those joints or butts have to be spiked fairly deep to the previous underlying laminations there. And there's a formula for nail length and nail spacing based upon the overall span and the individual pieces in the laminations. So here is just a schematic calling out the actual spacing and the reference, the specific reference to fastener schedules and the toe nailing requirements that are going to be called out. So this is just an example, a schematic of how this might look out in the field. You can see the larger nails and also the grouping and spacing of the individual nails making up the assembly to resist those loads. And here's that table I was referencing, fairly large nails. You can see we're looking at 4 inches and up to 0.192. Really common nail size might be 0.121 or 120. 0.148 or 0.131. So you can see that the diameter and the size of those nails used in terms of face nailing, up to 4 inches in length, 3.5 inches in length. So these are good sized nails. Again, referencing the common nail sizes typically associated with those diameters and lengths, not a clipped head or a box head nail. Common nail sizes. So the actual CLT wall thicknesses that were called out were changed, going from that 4-inch minimum to the 6-inch minimum thickness for exterior walls. And again, we're going up to that 2-hour fire resistance rating. We still have the requirements for fire retardant treated wood, FRTW. Again, the 15-30 seconds. The gypsum board and the non-combustible material, and again, the provided clarification, the 4-inch minimum thickness of CLT was versus the overall 6-inch thickness of CLT, and calling out the differences between the fire resistance, the prior fire resistance. So now we're up to 2 hours of fire resistance to comply with E119. And the total wall assembly thickness has to be 6 inches with a minimum thickness of 4-inch associated with the actual cross-laminated timber component. So you can see we have that not less than 6 inches in thickness with a 2-hour wall assembly, still spelled out in 602.4.2. So there is a heavy timber exemption. Again, the inherent fire resistance of heavy timber is well known. A lot of the old mill buildings would burn for quite some time. Once the combustible materials of the room and contents were exhausted, there's no more fuel. The fire is basically self-extinguished. That behavior has been modeled and reproduced in modern test labs. So that led to more data and research about the potential for exposing mass timber elements commonly associated with the new type 4B construction on the code. But the traditional heavy timber construction method still has some exterior, interior bearing and exterior bearing requirements for fire resistance. So exposed portions of structural building elements complying with requirements for type 4 heavy timber shall not be subject to interior finish requirements except for those systems associated with egress, like exit stairways, interior exit ramps, and exterior and exit passageways. So the previous version of the IBC had some exceptions for exposed heavy timber elements within those spaces associated with egress, like those exit enclosures. That was a life safety and exit issue, or life safety and egress issue. So that has been addressed in the 2018 here in section 803.3, and again referencing the wood chapter in section 2304.11. So that was a life safety issue that was corrected from going from the 15 to the 18. So traditional wood floor coverings have been exempt from fire protection and fire resistance criteria for quite some time. If you think about the thickness of the floor assemblies associated with these heavy timber structures, putting an extra layer of solid wood flooring is only going to increase the inherent fire resistance of that assembly. Those exposed portions of type 4 structural members are exempt as well from the interior finish requirements, and that section would be 804.1 and 803.3 in the IBC. So you can see that there are our Butler building example. This is fully sprinklered as well, but we would have exposed heavy timber floors complying with those individual requirements for individual thicknesses associated with those assemblies. So there was a proposal which was G178, makes it clear that structural composite lumber should be considered equal or equivalent to heavy timber, and it clarifies the appropriate distinctions between nominal dimensions, net finish dimensions, and actual dimensions for things like heavy timber, glulam, structural composite lumber, and cross-laminated timber. So you can see in the highlighting there, we're looking at minimum dimensions for materials, glulam, structural composite, and CLT. As long as they have those minimum requirements and meeting those minimum fire resistance ratings, you can use them. So chapter 5 and 6, heights and areas, types of construction. This is a very useful document, the Code Conforming Wood Designer, CCWD. This is available on our website for free. It typically is updated to fall in line with the triennial editions of the ICC or the IBC in this particular case. This is a joint publication between the American Wood Council and the International Code Council, and it specifically focuses on the combustible types of construction, commonly referred to in the code as types 3, types 4, and types 5. So the International Building Code has specific applications that permit a specific application of wood in those typically non-combustible construction types like type 1 and type 2. And those provisions for using combustible wood materials in those type 1 and type 2 buildings would be called out in these two chapters, chapter 5 and chapter 6. If you're a plan reviewer or you're an architect or a professional designer, it's worthwhile to download a copy of this. It has a tabular format for looking at things like building occupancy type and type of NFPA sprinkler system, whether it's an NFPA 13R system for life safety and protection for residential occupancies, or if it's a full or complete NFPA sprinkler system, NFPA 13, for life safety and building safety. It gives you approximate maximum square footage per area, square footage area per floor, and the associated number of stories and overall height for those types of construction in type 3, type 4, and type 5. So it's much better than, much easier than using that perimeter area, open space perimeter area formulation that's called out in the IBC. Just makes it a little bit more user-friendly to deal with if you're designing with those types of combustible construction, types 3, types 4, and types 5. So chapter 6, this is just nuts and bolts. It defines the different individual types of construction going from type 1 all the way to type 5. Again, we know that types 3, 4, and 5 are more commonly associated with wood construction, and we know, pardon me, within limitations, we can use combustible wood materials with limitations and fire resistance criteria in the more commonly associated non-combustible types of construction, type 1 and type 2. So type 5, again, is any materials permitted by the building code. We commonly think of it as stick frame or light frame repetitive wood. We also can use light gauge mild steel studs as well to construct these buildings. Any materials permitted by the code. They may or may not have 1 hour fire resistance ratings associated with type A or non-protected type B. So type 5, Roman numeral 5A, protected, 5B, unprotected. And you can use type 4 heavy timber on these buildings. They're permitted, those materials are permitted by code. So it would be a unique design element to incorporate repetitive light frame wood studs, typically covered up with non-combustible gypsum wallboard or drywall with some heavy timber elements as well. It'll be perfectly permitted to do so. In type 4, in this particular photo, we're illustrating a common pedestal or podium building. So 4/1 is a really common configuration for a fully sprinklered building in the IBC. More commonly associated with your R2, multifamily dwellings, have to be residential, have to be protected with sprinklers. So with real estate being the way it is and being as pricey as it is, instead of having a separate standalone parking garage, you're allowed to do a 3-hour horizontal separation, typically reinforced structural concrete or protected steel with a fully sprinklered NFPA 13 sprinkler system in the garage area. And then that 3-hour horizontal separation cordons off the rest of the building above. They're typically vented. They have fire and smoke vents in them because you're going to be parking cars with gasoline and other fuels underneath the typically R2 multifamily dwellings. So there's specific criteria in section 510 in the IBC for those podium style or pedestal style buildings as they're commonly referred to. In the 18 for type 4, we can have exterior walls, again, typically constructed of non-combustible materials, fire retardant treated wood, or protected cross-laminated timber, interior elements of solid wood or laminated wood without concealed spaces. And that's really the issue with type 4 heavy buildings. Think about your more modern, dining places have exposed ductwork, have exposed wiring and conduit, stuff like that, typically painted black just to kind of blend in with the ceiling. But you don't have the opportunity for chases and concealed ductwork, associated with type 4 that you do with other types of construction. So that's a design consideration as well. So there are criteria for that. So here's a really historic example. I believe this is the Yellowstone Inn. So there's just a massive heavy timber building. They've decided to go with natural crook construction for the posts and the bracing here. In this example, you can see they actually have laminations of unpeeled logs for the roof assembly, and then solid sawn beams and columns. Again, this will be sprinklered as well, but we have minimum criteria for columns, beams, and girders, and that's actually in a table in the IBC. You can look up those requirements there. But minimum specifications typically spelled out as nominal dimensions. You can see just the robustness and the strength of the framing depicted in the photo. So some requirements for those type 4 heavy timber dimensioned floors, roof decks, and individual partitions. Again, you're not going to see stick frame or repetitive light frame wood construction in these assemblies. So you have to have 3 inches minimum for the floor, and with 1 inch nominal dimension tongue and groove flooring, or again that 4-inch minimum cross-laminated timber. Your roof deck has to be pretty robust, 2-inch thickness, individual 1 1/8 thick wood structural panels, or 3 inches of CLT, and then your individual partitions must be fire resistance rated for 1 hour, and have 2 layers of 1-inch minimum nominal board thicknesses, or more heavy timber, conventional cross-laminated timber thicknesses, 4 inches or more. Again, type 3, traditionally non-combustible exterior bearing walls can be fire retardant treated wood or protected cross-laminated timber. We get into a little bit previously your A and B designation. Your A types have fire resistance, your B types do not. So you still have to meet the individual criteria for construction of the structural elements associated with type 3A versus type 2, but you have the additional criteria for life safety for 1 hour fire resistance for building materials other than the non-bearing walls. So the bearing walls would be 2 hours in a type 3 structure. If you move into type 3B, you don't have any requirements for fire resistance rating other than that stringent criteria of 2 hours for the exterior bearing wall. And you can use CLT in type 3 buildings, provided you do so in compliance with 602.4.2. So the next slide here, we just have a prime example of a type 1 or type 2 structure. In those types of construction, the building elements are required to be non-combustible. So in section 5 and section 6 of the code conforming wood design, it's going to spell out where you can have limited placement of wood materials in those non-combustible types of construction. Again, we talked about the capacity to have combustible materials like wood construction in the roof assembly, and provided you have those minimum fire resistance rating requirements, and that would be in table 601, footnote C, I believe, for 1A. So getting into chapter 5 a little bit more in depth, when the IBC was first published way back in 2000, wood buildings were allowed to have heights and areas commensurate with the largest buildings permitted for each construction type under at least one of the original regional legacy codes. So the Uniform Building Code, the BOCA code, the Southern Building Code, the Western Building Code, stuff like that for those uses. So that table, which is table 504, and again, the provisions in section 507 has continued to expand over the years, just getting different types of materials included and calling out those specific heights and areas. Not too much has changed versus the overall height. Again, the code addresses equivalent risk with equivalent performance. So your type 1, your type 2 structures have a lot of unlimited heights in them because the inherent fire resistance criteria of 3 hours. And they're non-combustible materials like structural steel. They don't really burn. But they have to be protected just like everything else, every other type of construction. So again, equivalent risk, equivalent performance. You can go taller with non-combustible materials. You step down in size as you start to have an amalgamation of combustible and non-combustible materials. And then you get all the way out to type 5, where you have light frame, repetitive wood light frame, or light gauge steel. Again, not as quite as robust as heavy timber or other mass timber elements. And your fire resistance steps down from 3 hours to 2 hours to 1 hour across those tables as you go from type 1 to type 5. So quite often the threshold in size for wood structures that are combustible have often been determined by structural consideration in terms of load and capacity rather than the limits imposed by the code. So there's a little give and take there with those heightened areas for wood construction. You can see different types of occupancy classification and focusing again on the combustible types of construction, types 3, types 4, and type 5. You can see the overall height limits for sprinklered versus non-sprinklered buildings. Again, for example, if you look at a business occupancy, the second one there, A for assembly, B for business, type 4 heavy timber, fully sprinklered, we're looking at 85 feet overall height, and then that works out to 6 stories, and we'll show you that on the next slide here. Again, looking at the business occupancy, fully sprinklered building, maximum number of stories permitted above grade would be 6, and you have to compare and contrast these limits here in the 8, 15, and the 18 with what's coming in the 2021 with the new type 4 construction limits, type 4A, B, and C. And just continuing on, showing you in the table what the maximum permitted square footages would be for the different occupancy types associated with types 3, type 4, and type 5 construction methods. You have the S1 there, which is single story, and then you have the sprinklered designation below that. So NS for non-sprinklered, S1 sprinklered with 1 story, and then fully sprinklered. So you can see for a single story building, you get to go a little bit bigger because you don't have the issues associated with egress and firefighter search and rescue and firefighter access associated with 1 story than you would with a multiple story building. So there are some times in the building codes when you get to increase your total square footage permitted for those structures. And that's typically associated with when you have a NFPA 13 or a complete NFPA 13 sprinkler system, pardon me. So you're allowed to increase your allowable floor area up to 3 times if you're a single story building. Again, equivalent risk, equivalent performance. So fighting a fire in a single story building isn't as challenging as it would be in a multi-story building. So you get to increase your allowable floor area 3 times for a single story building, provided it's sprinklered. And the same with a multi-story building. You can increase it 2 times. And the code references this 300% and 200% increases. So you have those criteria for square footage, and in the 18 you have section 504, which also permits the building heights to be increased by 20 feet and the number of stories above grade plane to be increased by 1 story. So if you look in the code in tables 504.3 and 504.4, that'll depict that very well for you there. And that's for all occupancies that are addressed in the code conforming wood design and the IBC. The only one that doesn't fall into that criteria is some of your institutional occupancies, your group I2 and group I1 for your condition 2 occupancies, which you have some limitations for self-rescue there. You don't get those increases for number of stories just because you have automatic sprinklers, because you have egress issues with your patients in those institutional occupancies. So you get the, if you have an R occupancy, a residential occupancy, you have a similar height increase, but you don't get the allowable area increase if you're using the less than complete NFPA 13R. Again, 13R for residential compliant sprinkler system allows you to go up to 60 feet in height and 4 stories. Again, that's depicted in table 504.3 in the IBC. So there again, there's some equations for open space perimeter and the total number of stories that are spelled out in the IBC. You can see we have an example of that equation here. Again, the code conforming wood design circumvents that and just gives you those calculations in total number of stories and square footage, so you don't have to do all the math. But you're basically looking at the equation 5-1 and equation 5-2 and the IBC. And what that formula basically does is it has a default value of 3 stories in the calculation that's going to determine what the total square footage area that you're allowed to have based upon the building occupancy type and the type of construction. And we're going to actually just walk you through that. So the text in green here, the S sub A, is the actual number of stories above grade plane not to exceed 3. So that this in the calculation on the bottom where it says A sub A and then the brackets times SA, that is going to line up with equation 5-2 in the code. And again, that's for an automatic, those are for buildings with automatic sprinkler systems that have the actual number of building stories above grade plane not to exceed 4. You still have to use that 3-story, that S sub A equaling 3 in the calculation, and we'll walk you through that on the following slide. So we have a 4-story building again, so we're beyond the scope of the equation for the 3-story maximum. So we still don't get to go over the maximum square footage. So if we look at the maximum square footage permitted for 3 floors, we're at 108,000 square feet per floor. That gives us a maximum square footage of 324,000 square feet for this particular example. For those of you with your calculators handy, since we can't exceed that 3,024 square feet, we're not going to divide that by 3. We're going to divide that by 4, which is the total number of stories that we have in our prototypical example here. So we're down to 81 square feet per floor, not 108,000 square feet per floor. So we don't, we wouldn't get that if it was a, we wouldn't get a frontage increase for a type 4 building because we're already maxed out for that single story. So we'll show you some examples here of some fire resistance ratings, and these are spelled out in table 706.4. Many of your occupancies here are shown as 3 hours. You have your H1 and H2, which are your hazardous occupancies, and then you have your factory and some storage and R3 multi-family, transient, hotels, motels, sort of things as 2 hours. So when we talk about fire resistance in the code, we're being very specific in the IBC. Firewalls, again, are probably your most stringent criteria, and they're defined in section 706. I just want to really hammer home the point here that these are very specific and individually defined terms. A firewall is not a fire barrier, a firewall is not a fire partition, nor is it a smoke barrier, a smoke partition, or horizontal assembly. So they're very, very specific. Firewalls are typically required to have protected openings, which restricts the spread of fire and extends continuously from the foundation up to or through the roof. and it typically was required to have structural stability to facilitate a collapse of the adjoining space from one side without collapse of the firewall. So it's not going to withstand fires on both sides, but if a fire is starting from a single source and it's working its way through the building toward a firewall, that affected area that's burning could effectively structurally collapse, and the firewall would maintain its integrity. So it's a very robust and very closely and tightly regulated section and definition in the building code. So firewalls shall be of any approved non-combustible materials in section 706.3. There is an exception there for type 5 construction. So if you look at the fire resistance ratings typically associated with R occupancies or residential occupancies, they will be listed as 3 hours. If actually we can go back, if you look, you can see our R1, R2 occupancies is 3 hours. That's that footnote there. The exception would be for type 5 construction because it's combustible. So typically firewalls associated with type 5 construction are 2 hours. Again, they can be wood framed, and they're calling that out there for type 5. And type 3 and type 4 has to be non-combustible in accordance with 706.3. So there are material restrictions for firewalls. A firewall for a very, very common detail for a firewall associated with type 5 construction would typically be 2 layers of 5/8 type X drywall on both sides combined with a 2x6 stud assembly. And there would be some non-combustible insulation associated with that as well. Remember, a firewall test, wall assembly test, an ASTM E119 assembly test fails by having flame front pass through the wall assembly, or having such increased elevated temperatures within the wall cavity that they exceed the test criteria. I believe it's 250 degrees. If it gets above 250 degrees in the wall assembly, the test stops. You fail the criteria for the testing once those temperature limits are reached, or once the flame penetration goes through the assembly. So there are provisions, again, for those similar to our podium discussions in 510.2. Special types of buildings, you're going to be looking at 3-hour minimum fire resistance rated assemblies between the lower and upper buildings. If you have vertical offsets in the horizontal assembly, then the offsets in the structure supporting such offsets will also have to be fire resistance rated for the minimum, which in this case is 3 hours. So the lower building must be type 1A or non-combustible. The upper building type and construction and building height and stories are determined if it did not have a building below. So essentially giving you that pedestal criteria. So you don't count for the floor, so to speak, but you do have to count for the overall building height in feet. So you're limited to the grade plane there, and we'll show you a little bit better example in the following slide. You can have Group B, Group M, Group R, and Group S occupancies, including S2 for open and closed parking garages permitted in the lower building. But of course, it has to be fully protected by an NFPA 13 sprinkler system. And you can also even do some limited Group A assembly occupancies prior, as long as your occupant load is less than 300 individuals. You can basically do any occupancy in this lower structure with the exception of the hazardous occupancies. So here's an example of that. We have our grade plane depicted there with a brown line. We have our closed parking garage with a 3-hour fire resistance rating. We have a total of 5 stories. We're not exceeding the 60 feet, but we're getting our 4 stories in for like a Group R occupancy above that parking membrane. So for Group R occupancies, the number of stories of a building within a single story group S2 parking garage of type 1 construction, or an open parking garage of type 4 heavy timber construction, with a grade entrance will be depicted in section 510.4. Again, we're measuring from the floor assembly for that parking area. The floor assembly between the parking garage and the group R occupancy above must be the type of construction required for the parking garage. In other words, it has a fire resistance rating the same as below. The floor assembly between the parking garage and group R must be the same as above as it is below. So even though it's group R occupancies on the floor of the first level here, the first floor of the residential occupancy, it still has a 3-hour fire resistance rating. So it's typically going to be non-combustible materials unless something is otherwise permitted. Open parking garages, again, we talked about these. You can have several occupancies below, with the exception of those hazardous occupancies. In section 510.7, there's some other alternative conditions that are separate and independent of section 510.2. The upper building heights and areas are listed on the slides that we previously discussed, and the open parking garage stipulation is regulated by section 406.5. You could use that a type 4 heavy timber if it's open. It can't be used if it's closed. That's one of the questions we typically discuss on these presentations. Give you an option whether it's permitted for open or closed, and it would not be permitted if it was type 4 heavy timber construction, but not be permitted if it was a closed parking garage. There were several notable fires on the East Coast and around the country associated with type 5 buildings with unprotected attics. So the NFPA 13R sprinkler system did not really adequately address the unprotected attic or lofts, unoccupiable loft spaces in some of these larger type 5 buildings. So they were typically constructed of materials light gauge steel, repetitive repetitive light wood framing, but they didn't have any provisions for sprinkler in the attic associated with the lower pressures and lower water volumes with the NFPA 13R sprinkler systems. Just an easy way to remember the difference between 13R and 13. 13R for residential has a volume requirement of 0.05 gallons per square foot, and a NFPA 13 system has a volume criteria of 0.1 gallons per square foot of area. So you're basically doubling the volume going from NFPA 13R to NFPA 13, and as well NFPA 13 addresses things like concealed spaces, attics, interstitial spaces between floors, closets, the dead-end hallways. All that stuff is addressed with NFPA 13 systems, not so with NFPA 13R, mostly egress, bedrooms, common areas, not closets, things like that. So there are just a little bit of gaps and some shortcomings, and these fires that occurred in these attic spaces really addressed a flaw. So there was a code change that was passed for buildings protected with the limited sprinkler system NFPA 13R for the combustible types of construction in 3, 4, and 5. As an alternative to sprinklering the building, you can construct those spaces with non-combustible construction, fire-resistant treated wood, or fill in the entire space with non-combustible insulation. And you reduced the eave height of these buildings protected with NFPA 13 slightly lower to make things easier for fire department access. And instead of measuring the average height of grade plane, we're now determining that measurement from the lowest level of required fire department vehicle access. In other words, how close can the firefighters get to the building? And if they can get to the building, we want to measure those reduced criteria, more stringent criteria from the level of the fire department vehicle access, can get in there and reach the building. With the definitions for the average height of grade plane, a lot of the developers were using things like retaining walls and other man-made structures to kind of define or tweak their average height of grade plane. But unfortunately, a ladder truck or a fire engine pumper can't, access a recreational or pedestrian walkway. Has to have full access around the building. So by calling out the criteria for lowest level of fire department access, we increased life safety in these types of combustible buildings protected with NFPA 13R sprinkler systems. So in the 2018 and follow-on editions of the code, when we talk about exterior walls constructed of mass timber elements and structural composite lumber assemblies, they're using NFPA 285. So an NFPA 285 test is a fire rated assembly for a non-combustible type of wall assembly. So even though that mass timber or structural composite lumber or cross-laminated timber is a combustible building material, we're still subjecting those exterior wall assemblies to the stringent NFPA testing criteria associated with non-combustible wall tests. And that's a change that made it, again, transferred through from the 18 to the 2021 because we're going taller with the mass timber buildings, much taller than the currently permitted 85 feet and 6 stories. So we have, I believe, one more polling question after this, I believe. So in IBC section 510.2, a building shall be considered as a separate and distinct building for the purpose of determining what? The height and roof above, height of roof above grade plane, area limitations, continuity of firewalls, all of the above, or E, B, and C. Like I said, don't hesitate to vote. Feel free to vote your opinion or what you think is the correct answer. This is not going to affect your CEUs or any certificates that are awarded. So I'll give you a couple minutes to vote on that. Hopefully you were paying attention to the previous portion of the program. And the answer we are looking for there is E, B, and C. So we want to look at, pardon me, the area limitations and the continuity of firewalls. So 2021 IBC related to mass timber. So this is the first time this definition appears, is the 2021 IBC. The mass timber or tall mass timber is now recognized in the IBC, and that has some specific, very specific connotations, as you'll see here in the 2021 IBC. So fire resistance ratings in table 601, this should be bread and butter for designers and for plan reviewers and code officials. You can see we have the traditional type 1, type 2, type 3, and type 5, and the type 4 provisions have been broken down into essentially 4 different building types. We have the new type 4A, type 4B, and type 4C, and we've actually broken off the type 4 HT, or traditional heavy timber, with its own HT designator. So you can see, just looking at the overall composition of table 601, type 4A most closely aligns with the fire resistance ratings associated with type 1A construction. And type 4B lines up very closely with type 1B. That's not a coincidence, that's not a mistake. Remember, type 4 construction is a combustible building material. We want to make sure that if we're going taller and larger with these structures and increased number of stories, that we have more robust fire resistance. You can see for exterior walls, we still have 2 hours in type 4 HT. but we just have an HT designator, which was assumed to have a minimum fire resistance rating of 1 hour. Never really tested with the traditional type 4 heavy timber framing method, but assumed to have a minimum fire resistance of 1 hour. You can see for type 4C, which is a fully exposed type mass timber building, we're essentially doubling that fire resistance and still holding the minimum threshold for fire resistance commonly associated with type 1B, even though it is a combustible building. The same with type 4B, we're still at 2 hours on the primary structural frame, the exterior and interior bearing walls. So it's a very, very robust fire resistance package. And there are even requirements for floor toppings associated with the taller types of construction, type 4A and B. And we have some fire resistance ratings there for the roof assemblies as well. So footnote G in table 601 has criteria for heavy timber bearing walls supporting more than 2 floors shall have a fire resistance rating of not less than 1 hour. So that can be protected. In fact, the members of the Tall Wood Building Ad Hoc Committee were emphatic that the structural strength of the mass timber elements themselves contribute to the inherent fire resistance of the building. The code change works out to be 2/3 of the fire resistance is provided by non-combustible protection, typically gypsum wallboard or drywall. The other 1/3 has to come from the inherent fire resistance of the heavy timber element themselves. So in this little example here, we're going to show you, we'll go back there, we have some non-combustible protection there in the form of gypsum wallboard on the exterior, or we can have it bare. If we have it bare, we need to document and prove that as this wood chars, we need to ensure we have enough structural mass to resist those design loads and live loads in terms of whatever fire resistance rating we're using. So if we want to have some exposed wood, let's say in type 4B heavy timber, then we're going to need to oversize those panels. If a 5-ply panel will work, if we want to expose any portion of that 5-ply panel to a 2-hour fire resistance rating exposure, then we need to upsize the size of that panel to account for that char, so that the panel or the exposed beam or column or floor or wall assembly can char and still have enough residual strength left in it to support all the design loads, plus a factor of safety for egress and firefighting operations. So if you're going to have exposed wood, it needs to be protected. And there's very detailed provisions in the IBC. Again, this is just an introduction, so we're not going to get into it too heavy, but we have provisions for type 4 heavy timber. You can start to accommodate concealed spaces in the type 4 heavy timber. Again, the traditional heavy timber construction, 6 stories up to 85 feet, has to be fully sprinklered with an NFPA 13 system, and those automatic sprinkler systems have to provide protection for those concealed spaces. Those concealed spaces have to comply with either the sprinkler provisions or be completely filled with non-combustible insulation, or those surfaces, ductwork, chases, and the like, have to be fully sheathed with not less than 5/8 type Beck gypsum wallboard, which is good for 40 minutes. So if we have a small fire in a combustible chase or some ductwork, it has to be lined, not the ductwork, but the chase itself, the concealed space has to be lined with 5/8 type Beck gypsum wallboard, which is good for 40 minutes. There are some exceptions for concealed spaces within interior walls and partitions that already have a 1-hour fire resistance rating. Again, the type Beck gypsum wallboard is good for 40 minutes. The criteria for concealed spaces at interior walls and partitions with type 4 is already 1 hour, so it exceeds sees the fire resistance rating of the chases or concealed spaces by 20 minutes. There's also clarification regarding the minimum thickness associated with CLT walls. Again, the overall wall thickness dimension is spelled out in the 18 was 6 inches, and then with details calling out the cross-laminated timber components as being 4 inches. So this change goes from that overall wall thickness to a specific actual dimensions associated with the cross-laminated timber assembly. So heavy timber structural members pertinent to the CLT exterior wall shall meet the requirements of Table 2304.11, again the wood chapter, and be fire resistance rated as required for the exterior wall. The exterior surface of the cross-laminated timber and heavy timber elements shall be protected by one of the following. And this will allow for protection and use of things like glulam and structural composite lumber and exterior walls associated with Type 4 heavy timber construction. Again, calling out the 2-hour rating, but eliminating the overall 6-inch requirement. Again, has to be 4 inches thick minimum, and those minimum structural dimensions have to comply with Chapter 23. So getting really close to the end here. Thank you for your patience. There were some minor revisions in the 2021 that corrected some errata. And you can see there was a story that got inadvertently lopped off with heavy timber, and that was revised in the 2021 IBC to correct that clerical error there, going from non-sprinkler to 5 stories to 6 stories for an S2 occupancy associated with Type 4 heavy timber. So that gets us right up to the end here. You should be able to identify Type 4 construction, including allowances for height and area. You should recognize new mass timber products such as cross-laminated timber, mass plywood panels, and the like. Introduce and describe the new provisions for the introduction of CLT and structural composite lumber in the 15, and then make the transition from the 15 up to the 18 for mass timber products and Type 4 construction. So again, this is part of a webinar series. We've done this previously. We have an upcoming webinar on December 10th, which is right around the corner, which we hope you'll join us for, specifically fire and connection design and special inspection associated with the new Type 4 A, B, and C types of construction. We also have some great resources, some great free resources for you at awc.org. There's an education tab on the top of the screen there in black. You can click on that. That has this presentation as well as PDF copies and also links to YouTube videos and other recordings of previous presentations. Most of the presentations that you'll see listed there have recordings done, like this one is being recorded as well, where you can tune in and listen in. And since we are an ICC preferred provider, you can go to the ICC's page and self-report. We already talked about folks needing AIA accreditation. You can provide your AIA number if you sit through one of our presentations. And if you give us a valid email, we'll be happy to get you a certificate in a couple of days. I'd be remiss if I didn't make a shameless plug for the construction fire safety resource that's listed on our website. Construction fires are preventable, and unfortunately they're all too common. They really just devastate our communities, and there's lots of free resources there for code officials and design professionals and even builders and contractors to help them comply with the new construction fire safety and safeguards during construction that were passed in both Chapter 33 of the Fire Code and Chapter 33 of the Building Code, which is going to be the law of the land when your state or municipality adopts the 2021 version of the codes. So again, I just want to thank you for tuning in today. Our contact information is here. If you have any questions, you can reach out to us at info@awc.org. Again, my name is Matt Hunter. I'm the Northeast Regional Manager. You can reach out to me at mhunter@awc.org if you have a wood design question. We have a team of brilliant and engineers on staff here to assist you with any wood engineering design questions you might have, or any code compliance questions you might have. So there's some contact information for you there. If you have any questions regarding this presentation or potentially scheduling any other continuing education for your group, we'd be happy to hear from you. Thank you so much for your time and attention today, and we look forward to seeing you on the next program. Thank you and have a great day.